I see already on top of the stream that John is there. Oh, yes. Hi, John.
How we go?
And John is located in the northern part of Norway. It's beautiful out there. But you see that the Amsterdam Institute of Sports Science is just reaching out all the sites on the globe, not only around Amsterdam. And I'm happy that John is available to introduce us into the FENDURA project. And that project originated, of course, from Norway. And as we know, Norway is it's a large country, but with a limited number of people, only something like 5 million. And if you look to the number of Olympic medals Norway always wins, then they get much more medals than they just that they deserve. So they do something really smart, and maybe John, this is one of the things you do really smart over there. So the floor is yours.
Thank you very much, Jos, and thank you everyone for coming along to this really important session today. So as I was just introduced then, I'm part of the FENDURA project up here in Tromsø in northern Norway, and I'm the project leader. And I also have a small postdoc position in this project as well. And so for the next sort of 15-20 minutes, I'm just going to walk you through the background behind FENDURA, as well as also some of our preliminary results. But really, everything we're doing as part of the FENDURA project is building upon all of the work that's been done by the previous presenters, as well as other researchers and sports scientists and coaches around the world. So this is a really fascinating and important area. And so I'm really lucky to be a part of it. So I apologize, some of this is going to be what we've already covered, but I mean, it's the same thing again and again, right? Sports science research on female athletes, it isn't there, like compared to what we have for males. I believe I've already talked about this today, but 10 years ago, Joe Costello did a quick overview of a sample of sports science research papers. And you would think that 50% should have females just based on the 50-50 of males and females, but only 39% of the studies that he collected there had female participants in them. And then 10 years later, this was replicated by Emma, and it's the same, if not worse. Only 34% were females. And this is just indicative of the kind of situation. And again, we've talked about this for the past hour now, and it's a real disappointing sort of thing. And that's where the kind of research that we have been discussing is really critically important. Obviously, we can't just use male sports science and transfer it over to females because of the massive differences. These are hormonal differences, biological differences, anthropometric differences. We can't just treat female athletes and male athletes as the same. We can't say that females are just small males. And so that's why we really require female-specific sports science research. And I've added this slide in the last 15 minutes based on what we've been discussing, actually. I removed it for time, but I just wanted to quickly put it through because there were some questions around this already. So McNulty did this systematic review looking at the effect of menstrual cycle phase and exercise performance. And for the people who don't know, a systematic review simply gets a whole bunch of studies. So you can see this here. Each of those authors is a study. They accumulate all the results together, and then they look at it as an overall sort of, if there is an effect. If these black horizontal lines cross the blue dotted line I've put in the middle, it means that there was no significant difference due to the phases. And as you can see, the majority of these studies, we didn't see any effect. And overall, at the very bottom there, which I've circled in red, it shows that it appears across all of these studies, there was no effect of menstrual cycle phase on exercise performance. However, you can see there are some studies that have shown differences. And we see the same thing in a similar systematic review that Kirsty Elliott-Sale did, looking at oral contraceptives compared to naturally menstruating women. But again, you have the same issues and you have large study variations. And that's because we have small sample sizes in the studies, differences in the methodology, as the previous speakers have said. We have differences in, say, how they track their menstrual cycle, how they determine where they are in the different phases for the testing. So really, there's almost nothing that can be sort of easily said and confidently said from an overall sort of perspective. We still don't know if menstrual cycle phase or oral contraceptives or hormonal contraceptives alter exercise performance. And that's really when FENDURA sort of comes in. So we received approximately 3.3 million euro in funding to sort of do some female sports science studies. And this was funded by TFS, Tromsø Research Foundation, or Forskningsstiftelsen, which is in collaboration with my university of UAT. And I assume that the majority of you in the room are from the Netherlands. So just to give you a bit of an overview of where we're located, you can see on the screen a map of Norway. The campus I'm currently sitting in is the larger of the green circles in Tromsø. And we also have a campus in Alta, the top green circle. And I've put this pink line here to give an indication of just how far north we are. So that pink line is the Arctic Circle. So you can see that we are about 350, 400 kilometers above the Arctic Circle there. But the FENDURA project isn't just UAT. It's also in collaboration with some other fantastic universities around Norway. So NTNU in Trondheim, NIH and Høgskolen Kristiania in Oslo, as well as the University Hospital of Northern Norway up in Tromsø. And we work with different endurance teams, but these are the ones that Jos was really talking about when it comes to gold medals. Norway is obviously known for its high incidence in collecting gold medals in winter sports. So we see that in the biathlon and the ski federations that we work with. And we've also had a close collaboration with Olympiatoppen, which is the Norwegian Olympic Federation. And the organization of FENDURA, just quickly, I'm the project leader. I work closely with the project management team of Øyvind Sandbakk, Bente Morseth and Boye Walder, the extended team who are located in other universities. But it's really sort of based around these three work packages. So work package one is the PhD student Hannah Staff, looking at sort of a historical perspective in female elite training. Work package two, Tina, looking at more of a surveys of elite athletes and perception. So similar to some of the studies that we've discussed today already. And then work package three, Madison Taylor, and she's doing more lab-based kind of work. So it's a really good combination of these three work packages. And then finally, in my small position, partially, along with Eric Anderson in Mid-Sweden University, we also do some postdoctoral sort of research projects that extend upon FENDURA. So let's just go through some of these findings that we had from the three work packages. So as I said, Hannah Staff, who is a multi-gold medal winning orienteer, she has recently had this systematic scoping review accepted where she looked back through, and I helped her with this. We went through 14,000 previous research articles, and we were trying to really look into the long-term training and development evidence for female athletes. And the crazy thing that we found was there was almost really sort of no evidence that supported long-term training for female athletes. As in, there was no evidence that demonstrated the optimal way for us to develop female athletic performance over a longer period. And that's simply because the research hasn't been done. So there's this really big gap here that we need more research done over a long period of time. We will say that we did find some evidence suggesting that these important performance determining factors, so things like VO2 or race pace at lactate threshold, the really important in this separation between transitioning from junior to a senior athlete. That's really where we see the difference between athletes that make it at the elite level and athletes that don't. But realistically, apart from those sort of two findings, it was very difficult to determine any clear outcomes. She is currently doing quite an interesting additional piece of information that I'm really looking forward to having published. Honda's asked all of her old orienteering athletes, as well as marathon and other elite endurance sports, and she's gotten the training diaries from these women. And she's looking for, and these training diaries go for seasons and years and even decades, and really looking at how that training and performance develops over this time period. So this kind of results will hopefully feed into that knowledge gap she found in her first study. Work package 2, Tina's surveys, again, as I said, is similar to what's sort of been previously discussed in footballers here. But this, she surveyed elite level cross-country skiers and biathletes, and looking at the prevalence of hormonal contraceptive use, menstrual cycle, side effects and symptoms, and a whole bunch of different questions. And this was actually published already. And so across the year, they logged their training, and then they also logged things like their menses, and also their menstrual cycle symptoms, and a variety of other things. And I think a really interesting outcome of this second work package that Tina's found was that the majority of athletes used hormonal contraception. And I think that's a fascinating finding, because we are very focused on the menstrual cycle phase without potentially acknowledging that a large percentage of elite level athletes use hormonal contraception. In Norway, progesterone-only contraception is also very popular, more popular than the combined oral contraceptive pill, which also suggests there might be some other differences there. And another interesting reason was about 60% of these elite athletes, the reason they chose hormonal contraception wasn't just for birth control, wasn't just for the contraception method. It was also for reduction in menstrual cycle symptoms, and at least for the combined oral contraceptive users, how they could manipulate their menstrual cycle around training or competition. They could use it to maybe skip a cycle. And so they had some really interesting qualitative data that she got out of this larger scale quantitative survey. And currently she's writing up this other paper from that same data. And she's looking at hormonal contraceptive users and non-hormonal contraceptive users, and the period a few days before menses or withdrawal bleed, during menses, and then the period after that. I say withdrawal bleed to refer to the women who use hormonal contraceptives. And one of the interesting findings was, not surprising, but the menstrual cycle symptoms were more severe, they were worse during pre-bleeding and bleeding phases. But athletes with severe symptoms, so the more severe the menstrual cycle symptoms, the worse their sleep quality was, and the worse their physical and mental readiness to train. That might sound obvious. If you're feeling sick, obviously it's going to potentially impair with your sleep and your want to do training. But I think this is a really interesting sort of point, because we also saw that for some of the hormonal contraceptive users as well. And then the third work package, again, this is Madison's, which is the lab-based project. And so this is more of the kind of evidence that we talk about, where we're seeing if menstrual cycle phase could change performance. In this, Madison tested endurance athletes at 3 different points in a menstrual cycle phase, across 2 menstrual cycle phases. So early follicular, so during the bleeding phase, just after ovulation, and then midway between ovulation and bleeding again, the mid-luteal phase. And this is the traditional kind of study. This is the one that I showed at the very start with the systematic reviews, where it's a very tightly controlled. We used blood sampling to determine where they're on the phase, and we did a whole bunch of different performance tests. So jump tests, things like that. Lactate profile, VO2. And overall, based on Madison's research, we found there was no significant differences. She's also doing a similar study at the moment where she's looking maybe menstrual cycle phase. If it doesn't affect performance, maybe it affects sleep and recovery, which has some interesting aspects that links in with Tina's previous survey, suggesting that there were issues around the menstrual cycle phase and sleep. But to just show you the data from what Madison has found for her first study, you can see, so this is velocity at blood lactate threshold, VO2 max, jump height, and 30-second double polling on the ski ergometer. And you can see that the black line shows almost no difference between the three phases. And that suggests that there's no difference in performance between menstrual cycle phases. But what I would like to point out is you can see the thinner, lighter lines behind are individual athletes. And you can see that for some of them, there are some significant variance where we have some big differences phase to phase. And this suggests that, as the previous speakers have said, we need to really think of this as at an individual level. We can't just assume a group or an overall group outcome. Finally, some of the other research projects. So Eric and I did a similar thing to what Madison did, except we did it in not endurance athletes, we did it in team handball athletes. And we looked at if performance in team handball athletes differed across the menstrual cycle phase, but we also included hormonal contraceptive uses. Overall, our evidence shows there may have been some differences between the naturally menstruating group from their bleeding phase was when they were weakest, so maximal strength. We saw that in their 1RM squat and also in their 1RM in their hand grip. But this evidence is a smallish sample, so I think we need to do more research in there. We also found that menstrual cycle phase didn't have any effect on sprint agility and neuromuscular power. And when we think about a team sport like handball, those are really the performance factors that are going to make the most difference, not maximal strength. We're also doing some work around bone health of female athletes, similar to the red S kind of stuff that was discussed initially, as well as I've got a larger scale study that I'm currently writing up, looking at hormonal contraceptive use stratified by physical activity level. So we know what sedentary people or non-athletes use, the prevalence of hormonal contraceptive use, and we know what elite athletes use. But this survey will show it at multiple different stratifications. So recreational level athletes, moderately trained, and so on. I'm really looking forward to this kind of research. So some take-home messages then from the FENDURA project. Based on Hannah's data, we can see that there's almost no specific evidence that suggests an optimal way of long-term performance development for female athletes. And until we get that research, I would suggest that you consult with experienced coaches to try and develop the optimal plan for your athletes, and also get your athletes to track their training over time, because then that information can be fed in and we can use that for future research studies. From Tina's work, we can see that a high percentage of the athletes, at least the ones that she measured, used hormonal contraceptives. And one of the main reasons was to reduce menstrual cycle symptoms. And so something that we've mentioned again and again, multiple speakers today, we suggest that you track performance and training and also sleep and recovery when you're using hormonal contraceptives or when you're switching hormonal contraceptives from delivery method, so say from an IUD to an implant, because we did see differences between each of the different groups. And then finally, based on Madison's work, it seems that menstrual cycle phase probably doesn't influence exercise performance at a group level. However, and as Carolyn mentioned before, in the one size doesn't fit all, we should use an individualized approach. So for each athlete, we should approach them and you should ask them and talk to them, have a discussion. how do they perceive the menstrual cycle phase affects their performance? And that's something we need to think of. Just because menstrual cycle phase doesn't affect performance doesn't mean the symptoms from the menstrual cycle might also affect their performance. So it's sort of two different things there. So that's basically the whole presentation I have. But I would like to say I'm really interested in working in this field with other people. So feel free to reach out if you want to collaborate or to talk more about some of the work that I've done today. Thank you very much, and I'm happy for some questions.
Thank you, John. Are there any questions for John? And Dana?
Yeah, John, thanks a lot for this nice overview. I had two questions. The first one is, how big was your group? The group that was the package 3, I guess. The researcher who was looking to the women in the 3 stadia of the cycle. How big was that group of women?
Yeah, great question. So the group was, as of now, I want to say it was 24-ish. I want to say it was in the 20s. So that's a good example of when we initially started this. It was the kind of thing where we were going to assume that it was going to be, we're going to get 100 participants. The main and interesting outcome of that was a lot of the women that came in for our study, they were anovulatory.
Did you measure that? Did you do hormone level testing or just ovulatory testing?
No, we did a ovulation test to determine ovulation, and then we did a serum hormone test on the start of each of the test cycles. So the early follicular, the ovulatory, and the mid-luteal. So based on those tests, we were also able to remove people who had luteal phase deficiency, so a progesterone level of under 16 nanomoles per liter. And that's one of the reasons why Madison has a fantastic figure where she shows the number of people that we started with, 100 participants that have come in for testing. And then it just gets smaller and smaller and smaller as we, anovulatory participants or, yeah. So it's interesting. You really do have to have a large sample size. You have to start with 1,000 athletes or something. Thank you.
Yeah. Thank you.
Well, thanks.
Yes, so John, thank you very much for your interesting presentation. I was quite triggered or intrigued by the first conclusion you presented, that there is hardly any evidence for long-term improvements or training improvements in females. So I can see that you found that there is limited research on female athletes, and also that you then state more research is needed. But based on what you know now, would you think that we should treat female athletes as a different kind of animal? Or would you still think that most of what we know about training adaptations would still apply to women?
That's a insightful question, and one that I don't know if I have the ability to answer adequately. But we know that there are physiological differences in the training adaptations, but I'm unsure how I can comment on the best way to go forward when it comes to training. I would suggest that we should, at the moment, potentially combine the knowledge that we currently have from our female athletes and our coaches with the research that's been done on males. But that's really a stopgap solution. I would suggest, let's be honest, the optimal thing would be to have actual female-based long-term training. But in the meantime, I would suggest that that's our only real option. And I would suggest that's what's currently being done anyway. Does that answer your question?
Yeah, thanks.
And there is an online question.
Finally, an online question from the audience. Anna Stiefelman. Question: have you found any correlation between the severity of perceived symptoms and objective performance measures during your studies?
A great question, and that's one that we haven't, for Madison's study, the sample size wouldn't have been large enough to determine that. However, I have a large-scale study on the team handball survey, as well as the general population, and there does appear to be a correlation between self-perceived performance and menstrual cycle symptoms. Obviously, self-perceived is going to be different to objective measures, which is what you asked, but no. To answer you, we didn't find that for Madison's study, unfortunately. Or not unfortunately, but no, we didn't.
Are there more questions for John? And I would like to have a big applause for John.